Hey everyone! In this video, we're going to quickly go over how we're going to create a one sample t-test. So far, we've dealt with proportions and categorical data. Well, now we're ready to start in our quantitative journey. So it's known as a one sample t-test. And you saw in our formative as a homework the night before how it really got created with Guinness, which is so cool to think about someone really creating this to make it applicable to real life and how they test their quantity of a product. So we'll talk more about that in class together, but for now, let's kind of set up how we would set up our t-test when we're going for it. So what I need you to do is take out your Inspire calculator. It's been a little while, but if you need to, pause the video while you're getting that out. And when you're ready, the idea is that you should be adding a list and a spreadsheet. So I know it's been a while since we've done that. You can always add a page by hitting the blue control button, and then where doc is, you'll see that plus page. So click that and scroll down to list and spreadsheet. Once you have that open, you're going to put in these 20 pieces of data. So you have 20 in one list, these 20 items here. You're going to plug all of that data into your calculator. So again, hit pause and give yourself a minute to really make sure you know how to do this. Okay, one thing I'll remind you before you go past this page is you have to make sure there's a title. Remember that we can't call upon our data in the calculator without this title. So I would say call it ounces. You could really call it whatever you want, but to do that, you're going up to the very top of the list where it says A in that little tag and writing in ounces. So again, take a moment to make sure that's there. Do not write it where the equal sign is because that's used for pulling out different items with calculation. So quick check, you have your 20 total pieces of data in there and you've titled it ounces before we go further. Now, we're going to look here. We have our inferences about mean. Now, the item we're going to look at today is a coffee vending machine that dispenses coffee into a paper cup. You're supposed to get 10 ounces of coffee, but sometimes this amount varies from cup to cup. So these are the 20 items. Now, we've already plugged these ounces into our calculator for this. We want to know if the company is shortchanging people. So when I'm looking at that, we think that people are getting less than they deserve. So our first C is still intact. That's our choose. So we're setting up our hypotheses. So we still have a null hypothesis. Now, instead here, we are used to using P for the true proportion. We're using mu for the true mean. Now, remember, we always do what we believe is true. We're supposed to get this 10 ounces, so we have no reason to believe we're not. But our alternative comes from this short changing of people. So we want to see if that is getting less than 10 ounces. And in the same regard as what we would do, what we're doing here is a one sample t-test where mu represents the true mean amount of coffee. And if we want to, we can include that unit. So I'm just going to put ounces in there. Okay, so it's all exactly the same as what we did with our one prop Z, only now things that are different. We have mu, which is for quantitative data, which is, remember, mu is used for the mean of the population. So just like we don't use p hat, we're not using anything else there. We made sure we titled it as one sample t instead of that proportion. And we're doing the true mean amount instead of talking about proportions. So those are the only differences of the setup with choose. Now our conditions are still going to be checked. So we still check random. So if I go back in here, random samples given, so we can just write that, our random sample given. We're checking our independence. We use our 10% condition here. So 20 is less than all of the cups of coffee. And now here's the new piece. We checked our ln for proportion. We're not going to check that anymore. Instead, we're going to check our nearly normal condition. So our nearly normal condition is a little bit different when I'm going through this. Instead of what we're used to with our ln and we're checking our proportions, we have a couple different ways to check this. So on the next slide here's some of my ways. So I could look at a picture. I'm going to come back for one quick moment and notice that it doesn't say that it's nearly normal, right? If I read through here, there's nothing that says it's approximately normal. So it could be that approximately normal was given. Okay, in this scenario, that was not the case. The second option could be my central limit theorem. So it's been a little bit since we talked about that central limit theorem. But remember, that would be that n is greater than 30, right? So whatever my sample size was would be greater than 30, which is not the case here because we're talking about 20. So that's not satisfied. So my third is my picture. So we can take a picture of the data. Now, to bring up a picture on my calculator, I've already typed in all my data. So this is where you hit your control button again. So on your Inspire, you're going to hit that blue control button and hit add page. And when I do that, I'm going to go down to data and statistics, the fifth one. Now, scroll that arrow to the bottom where it says click to add a variable. Ounces should pop up because we've put that there. And automatically, one thing you could see is that dot plot. So you should be able to see this dot plot over here. And now I would make a quick description of this data. So you would draw a quick picture to sketch this. Right now I'm giving you the actual pieces of the picture on my Inspire calculator, but you would have to provide a picture, right? You can't describe the picture if there's no picture. So if you don't have a picture, you got to do a quick sketch. And that's what I see on my calculator. You could also go up on the calculator and hit menu. And when you go into the plot type, all these different types come up. You could hit a box plot. That shows me there's no outliers. When I look at it, I could hit menu again, plot type, and I could go to a histogram or a normal probability plot. We see that in the top picture here. So whichever way you want to do that, but we look at those normal potentials. But again, you would have to make this sketch of your picture if a picture is not provided for you and all those other conditions are not satisfied. So this is what I would do for my conditions check. And now, since all three conditions are met, I proceed. And now we think about our calculation. So in here, what I'm going to do is now one more time hit control and add page. I'm going to go back to my regular calculator. So that's just one when I hit control or add page and then that menu pops up. You're going to hit menu, statistics, down to stat test again. And now we're going to hit what this says is the t-test, which is choice 2. It's going to give you two options. You can either put in data or you can use your stats. Now, I'm going to use data since I've typed it all into my calculator, so I'm just going to hit OK. So then you'll see that window that you're seeing as the snapshot up here. I plug in 10. When I go to my list, I hit over and get that ounces to pop up. Frequently list is 1. And I change my alternative to match the less than of my hypothesis. And now everything will pop up. So that's what I'm getting in this case. Now let me talk to you about a couple things here. Basically, from my data, those 20 items, the mean is my sample. So this is the equivalent of your p hat, but this is my sample, comes up as this 9.845. That S of X is given. That's my standard deviation of that entire sample. It's calculating it for me, that 199. N is the sample size of 20. And then we have our degrees of freedom. Our degrees of freedom come from n minus 1, as you saw in your formative. So that is all coming into play here, but you'll see all of that listed in the calculator. Now, the calculator by itself, of course, is not enough. So what we're going to do is we would still need to do our calculation. So, of course, that means we include a picture of our normal model where our mean is expected to be 10, our sample is that 9.845, and our hypothesis was one tail shade to the left. We should include that normal of that 10 and my 0.199 in here. So that's my idea of the picture. And now we're going to set up our formula. Now, when I set up this formula, I'm pulling it all from the reference sheet again, and we'll look at this more in class. But as I look at this here, I'm going to go ahead and have a t with our degree of freedom equal to, now it's the same idea. It's our x bar minus mu all over my standard deviation. So I want you to pause the video for a moment and look at the reference sheet. Pull it up real quick and see if you can figure out what our standard deviation is going to look like, and if you can recall that piece. Okay, you might have seen that it's your standard deviation over the square root of n. So how I'm going to set this up now, t of 19 is equal to that 9.845 minus 10 all over 0.199 over the square root of 20. Now you can plug that into your calculator as is, but again, if we look to our t value, that comes up as a negative 3.49. And if we did our inverse norm, we would get our p-value. Our p-value, again, you can get that from what we plugged in already, or you could plug it in with our norm distribution here, and we have 0.001224. And then the same as before here, I could make my conclusion. And when I make my conclusion, I've got a low p-value. So because my p-value is low, I reject HL. I have evidence to support the true mean of coffee being dispensed is less than 10 ounces. So maybe we are being shortchanged. The p-value in context, I'm going to just explain it quick as I'm going to wrap this video up for now. Remember, it's all based off assuming that the null is true. So given the null is true in this case, the coffee, or the true mean of the coffee, let's say, is 10 ounces. We observe a sample of what we got, that 9.845, about let's look back over, 0.12% of the time, or less, right? Or less. Oops, squeeze that in. Okay, so that's our starting point. I could do my confidence interval the same way you would plug it into the calculator. We'll talk more about this one in class tomorrow, but I wanted to set up the test for you today. So then we'll talk about how we set up the interval, and I will see you in class. Thanks.